theorem. So we'll start with the De Morgan's theorem. Have you listened about this De Morgan's theorem? Where in 12th class? 11th. Okay. So you must know about it. This is De Morgan's theorem, but this theorem states that he gave basically two theorem. Theorem 1, that is A B bar must be equal to A bar. Okay, I'm making it separate. Then we can say there is a dot. If there is a dot bar, then that would be converted into plus. If there is a plus bar, then that would be converted into dot. So dot bar means that would be added, and then B bar as it is. Okay, so this is basically the De Morgan's theorem. You can check it also by making the truth table. Like suppose we are having two inputs A and B, and as you know, if there are two inputs, how many are the possible combination? Tell me. 4. 0 0 1 1 0 1 0 1. Correct. So we'll make first AB bar. AB bar output is how much? 0 into 0 is 0, then 1, 0 into 1 is 0, then 1, 1 into 0 is 0, 1, 1 into 1 is 1, so 0 here. Now if we want to take A bar plus B bar, A bar is how much? 1 1 0 0, right? And B bar is how much? 1 0 1 0. Now if we want to add it, A bar plus B bar, so these two outputs must match with each other, like for AB bar and for this one. Next one, A bar B bar, we will add 1 plus 1 is 1, 1 plus 0 is 1, 0 plus 1 is 1, and 0 plus 0 is 0. So these two outputs match with each other. So this is verified by De Morgan's theorem. Okay, clear? This is theorem 1. Next we'll study about the theorem 2, that is A plus B bar. So what does it, like A bar plus bar, that is represented by dot, and then B bar. Okay, so if you want to draw the gate diagram, so how will you make it? A as it is, then we want A bar, then that would be A bar, then B as it is. If you want to make B bar, then we'll multiply it with the AND gate, and its output is A bar dot B bar. Clear?